Hello everyone. My camera is not working. Very good. Let me fix that. Oh, that's that. That looks better. Let's try it again. Hello everyone. Now my camera should be sending signal. Fantastic. Welcome to I think the fourth iteration of the animation generation collaboration. And this month we are doing Curves of Pursuit. Create an animation showing how a curve of pursuit is generated. And I'm not entirely sure what I want to do. What is generated means. What I'm thinking about is the following. So a curve of pursuit is basically this here. This is called the mice problem, right? So you have a point, let's say here at the top left corner, and a point at the top right, at the bottom left corner, and then the point in the top moves towards the point on the bottom, and the point at the bottom moves to another point in the bottom right, and so on, and then they chase each other. And in this case, it will lead to certain, I think, logarithmic spirals, and this is a general idea. So for example, if you have a point, I think, that moves on a straight line, you get what's it called, a radiodrome, something like that, and we want to do that. And as I said, I'm not entirely sure what I want to do. I think we should make a basic setup where we can have one point follow a second point, and then we see what we're doing. I think maybe the mice problem, and then we're going back to this how a curve of pursuit is generated. So maybe have a more explanatory animation where you can see how it is created, which then might be used in a lecture or a YouTube video or something like that. But let's start with a basic setup for this mice problem. I'm using Cindy.js again, of course, and I'm also using my custom animation library, which is probably not so super important for today, but let's see how it goes. And to start, so first of all, let's make a little bit of graphical stuff. I imported two old images from the video on population dynamics and Lotka-Volterra equations, a mouse and an owl. So let's see how that looks. Then we can use that. Draw image, canvas, center. Let's draw the mouse. Oh, not in calculation, of course, in rendering. And that is a nice size. I think we can use that directly. Great. So in preparation, I was thinking about how general I want to make that, and I want to make it a little bit general because we might want to do one or two variations. So we want to have entities, new entity. And in Cindy.js we have objects, which are basically dictionaries. Under the hood they are JSON objects. And we want to have something that has a position and a max pos and a max speed. And then we can move them around and hopefully do the animation nicely. So position. Then we want to store the velocity separately. Let's initialize it as 0, 0. We want to have the max speed of our thing, of our object, as the max speed we used. And then we want to have a target. So this is the main part, of course, we want to have other entities we can move towards. And let's initialize this as 0 so we can check whether we have a target. And now let's say we have a list of entities, so entities, then we should be able to do something like the following: for all entities, that's not a good word, entities, and then we can do the calculation we want, calculation, and then it's hopefully somewhat independent of how these things work. So this is what we have, and let's define a couple of mice. So first of all, I want to try to make it a little bit parametric, because you can do this mice problem with not with 4 but with any number. So let's say number of corners we want to start with. Let's start with 4, and then we want to have this arena where we start. So the arena is we go from 1 to the number of corners, and then we just have maybe 8 times ang to vec. Ang to vec is just sine, cosine, point on the unit circle. So we want to have 360 degrees divided by the number of corners times the generic running variable in Cindy.js, and now let's see how it looks. And we want to center it in the center of the screen, and then let's see what happens if we just draw. Nothing. Draw. It's a polygon, so maybe let's draw it as a polygon, right? So we have this upright thing because we started at 0. Let's make it like this, and then it should. Oh, why? Oh, right. Yeah, that's not the change we have to do. It's okay. Let's have this diamond. And now we want to have well, our mice. So let's say how do I want to make this efficiently? For all arena, so this is every corner. I want to have new entity. Let's call it M for mouse. M entity. Oh, let's because I want to have this cyclic, so I want to do this anyway afterwards. So the new entity sits at this position, and the max speed is, let's say, mouse speed 3 units, whatever it is. Let's see how it works. Mouse speed, and then we want to add this to the entities. So entities is entities added the new one, and then let's try to draw all of them. For all entities, draw image. The entity is now this dictionary, so at the position we want to draw a little mouse. Right, that looks good. And then we want to set the targets, so I'm doing it afterwards. So for all, let's make it like this number of corners. We want to say that entities for the entry we are looking at, we want to set the target, and it is the next one. So for the first mouse, the target should be the second mouse. For the second mouse, it should be the third mouse, and so on. The only thing we have to take care of is that the last mouse has to go to the first one, and because Cine.js has arrays which are one indexed, we have to do actual thinking here. If I put in 4, so if our running variable hash is 4 in this case at the very end, this would get to 5. And if we then make it mod 4, it will end up at 1. And if I put in 1, I'm very confused that modding directly would work. This should not work. Let me run through it again. So if hash is 4, then this is 5. 5 mod 4 is 1. That works out. And if I have 1, then it's 2. If I have 3, then it's 4. Then it's 0. Right. So is it this? I can never do this. I can never do this. Is it this here? No, that's certainly not. Now if I put in 1, it's 1, 2 is 2, 3 is 3, 4 is 0 plus, well, that should be the right one. 50-50 chance. And now let's see what happens if we let them loose. So what I want to do is I want to update the velocities. The velocity should point towards the target. So for all entities, I say I have a direction. The direction is the target position minus the own position of our entities. And then I say the new velocity is whatever the max speed is. And now I want to normalize the vector which points towards the target. But for numerical stability, it might happen that we're at the same position and then we divide by 0. So let's say if the length of our direction is 0, we just use the 0 vector, and otherwise we normalize. This is the new velocity, and now I calculated the new velocity for all entities, and now I can move them. Oh, why am I in delayed setup? I don't need to. In calculation, let's say. Calculation we want to do. And for the start, let's just move them. So I'm doing this in a separate for loop, because otherwise the first mouse makes all the updates and moves a little bit, then the second mouse moves a little bit, and so on, which could be numerically unstable. So we're doing this in a separate loop, and for the very small number of entities we have, it doesn't really matter. So we say the position is the position plus delta times the velocity. Delta is a variable in my animation package, which is just the time from the last frame, the length of the last frame. So we have, for all entities, we update the velocity and then we update the position, and beautifully. And then in the center it starts to wobble. So let's make this a little bit larger. Right. and at the end we would have to stop at a certain point. And if we let them move faster, fantastic. Now we want to make it. We want to see it, right? Let's get rid of the wobble. So what we want to do is we want to maybe have a little trail behind the mice. So where do I put it? Let's put it in the entity itself. Why not? Trail. The trail is an array, and at the start it just has the position we started at. And then for all entities we connect the trail. And let's see, because our mice are purple, let's say color is, I used the color from the YouTube channel, so it should be violet 1, I think. And now the question is, how often do we want to update it? We can update it every frame, but let's pretend that we are worried about performance. So we say trail counter max, let's say every 20 frames, so 3 times per second approximately. Trail counter is trail counter max, and then in calculation let's trail counter is trail counter -1, and then I will probably do it in yet another loop. So if the trail counter hit 0, first of all we want to set it back. Trail counter is trail counter max, and then we want to take the trail and add the position undefined variable trail. Oh yeah, we want to. All right, we can make it. Because we're moving relatively quickly, so let's say every 5 frames, and we have to stop at some point. But right, that's the mice problem, the classic curve of pursuit. We always move towards the target, and then depending on how the target moves, we get something out of it. So let's make it a little bit prettier. So first of all, make this 2, 5. Our icons are relatively large, so yeah, maybe that's enough. Maybe that's good. So, and maybe draw maybe draw the arena between them. So now the trail is under the arena border. Is that nice? Not really. That's probably good enough. Fantastic. And now let's turn this into a full animation. So we want to let's stop this wobble. We want to make the arena appear, then we want to make the mice appear, and then we want to let them move. So we go up to our track data. So in my animation package, we have the system where individual movements are determined by how long they are and how much pause is there between them, because that's, for me, what makes most sense in animations for YouTube videos. So let's title this properly. So let's say at the start we want to have draw the arena, then we draw the mice, and then we move the mice, and then we no, not move mice is not a move mice is not a movement. So letting the mice start is not a movement. So draw mice and move mice, or start mice at the end, and then quickly before they reach the center we want to stop. Stop mice at the start of this. That's not nice, but it will work. Okay, so first of all, we want to draw the arena. So, where's the arena? I think it's called animate polygon. Let's see if that works. So first of all, we remove the movement, and we remove the mice for a second. I think it's called animate polygon. Animate polygon should like construct the polygon. So animate polygon creates a moving point around the polygon we give it, and then we can connect it. So that's a really bad explanation, but you will see how it works. And we want to do this in the first movement. So T1 gives us the first movement. Right, exactly this. It's just that we don't want to draw poly, we want to connect it. Now we have to add we have to close it, so let's be lazy and do this. So it will something like this. And for the size, let's also make it a little bit thicker, and let's say we want to ease in. How do I do lines? Ease out circ. So this will have the line width at 0, and then it will pop up to whatever it is, to 2. Wonderful. Then we want to make the mice appear. So we do the draw image, and we want to change the scale. So we want to make it pop up. So this is ease out back in our second motion. Right. And now what I want to do is I want to make them appear in order. And I recently created a new concept to do this, which I call a ladder. A ladder, so this is in movement number 2. This ladder, what I call it, will subdivide a certain movement, in this case the second one, the progress of the second movement, into sized, so in portions of the same size, and you can say how much they overlap. So in this case we have number of corners, so we will have 4 sub sequences in our second movement, and now we can say how much they overlap. The last one is called separation. So if this is 1, they will be completely one after the other. So let's make it a little bit longer. And if it is 0, it will happen at the same time. and then you call this ladder. It's very weirdly set up, but for me it makes sense. You call it by saying ladder do step, which says, okay, if you call do step the first time, it will give you the progress within the first subsection, and if you call it the second time we go through the for loop, it will do the second subsection, and so on. And the explanation is probably very confusing, but you will see with 0 separation, it will happen at the same time. With 100% separation, what is going on? It should happen. Oh, ladder, yeah, I defined it in the loop. I have to define it in front of the loop, obviously. So, again, with 0 separation, it will happen at the same time. With 100% separation, they will be completely separate. And I think always something between 0.6 and 0.8 is often nice. Yeah, maybe a little bit less. Isn't that nice? And let's test it out with 6 mice. That's the mouse speed. I want to. Where's the number of corners? Where is the number of corners? Isn't it beautiful? And just for like a stress test, right? Even with 16 mice, it works quite nicely. So let's make maybe 7. And now we want to start them at the end. So at the again, ignoring efficiency. At the end, we say we want to update the position, but only if the second movement is finished. So if the second movement is at 100%, we want to start it. So we multiply by 1, and if not, we multiply by 0. And then they move inwards, and we draw also the... So we see that the trail, because it consists of a single point. Let's draw that if we manage that. Now it works like this. And yeah, at the start. So at the end we want to have the trails and the icon separated. At the end it looks like an aperture, or maybe like every icon of every AI company, which also look like something else, but that's okay. And now we want to stop. So let's get our debug tools back. Let's use the debug tools for now. And let's see when we want to stop. Let's make this very boring. They start at 3 seconds, and at 8 seconds maybe we can stop. So let's say let's get, yeah, let's make that. Where do I want to make that? So overall we have this is now the problem with the relative way to draw this. So let's say at 3, so for 5 seconds. For 5 seconds. It runs for 5 seconds and then very, very unelegantly, and then we want to say if T2 is at least 1 and T3 is still at 0. So as soon as we start with this third movement, which doesn't really do anything, we will stop our mice. So. Fantastic, why not? That looks like something. And just to see the 3 mice. Of course, now they are much quicker in the center, right? So we would have to adapt this pause. But it does work. Right, let's do 6. Fantastic. That's not too bad of an end point. Maybe make it a little bit earlier, and let's make the move a little bit slower. Let's see what happens. Right. And I still, because I haven't thought about this too much, the shape is the same. So this, the speed here is really just the speed of the animation. The shape stays the same, which makes sense. Does it make sense? I don't know. But let's say this is our final animation for now, and I think that's a good start. But now I also want to do this more classic, a hunter pursues a prey animal or something like that, and we can use our owl. Yeah, but that's the classic one. Okay, so let's just copy that because that's a good setup, and let's so let's delete everything. We don't need, maybe we want to keep the trail, I guess. We don't want to have the arena. We want to have the calculation. The calculation is the same, and the rendering, we don't render the arena. And of course for now, so let's say we care about the animation later, right? So let's set that back to something of a default value. So we have our entity system, we have the calculations, which are more or less the same, and then we draw that. Right, so nothing should be there, and no error messages. Fantastic. So we want to have a mouse and an owl which follows it. So let's do that. So because we have two different things, we want to define. This is now way too complicated, but that's okay. So let's call it species. So I can't is the species and again, let's make it slightly general so that I might be able to reuse it. So we have our mouse species, which I just say is the number 1, and our owl, which is 0 and 1, and then we have species data. So we have the mouse has image mouse and color violet 1, and the owl has image owl and teal 1. So again, way too complicated, way overblown, but if you just have 2, but it makes it nice to expand. So if you want to experiment with the code, it should be in the repository after I finish the live stream, which is linked in the description. And I'm also thinking about maybe using it for a YouTube video in the future. So a little bit of abstraction is good. So we have our species data, we have our species types, and then we just store that. So nothing happens. Let's define 2 animals. So we have our mouse. Does that work? Is that? I can't remember whether Cindy.js is case sensitive. Let's just call it. Let's just store it in the. So, new entity. I want to have it somewhat at the bottom. So let's say 0, 0. Let's see where that is. And the max speed is of the mouse. I think 4 was very nice, and it is a mouse. So it is a mouse. And for now, I want to have the owl, the hunter, above it directly for testing purposes. So same speed, let's say, and it's the owl. And nothing happens. That's very good. Because why is nothing happening? Why is nothing happening? Let's forget the trail for a second. Just the image. I should have scale set to 1. Can't be the problem. No, that's not. So what I want to have species data. And then I want to have something like that. For all entities, draw image. What's what is index out of range? I have no idea what's going on. So for all entities, let's say print line the entity. The position is, the position is broken. Why is the position broken? Oh, right. So what I'm doing here is I'm updating the position based on the velocity, and the velocity is updated based on the target, and none of our entities have targets. So first of all, I have to check if the target is not our 0 placeholder, and then I can do that. Fantastic. It still doesn't work because we only have one. There's still something weird going on. But at least we have one. So print line species data is a correct. I'm very confused. So the position is also index at draw image. So let's get rid of that. Live bug fixing, how fun. So, and if I say this one here. Oh, 0, 1, yes. As I said, Cindy.js is 1 indexed, and I'm currently working across multiple programming languages, so I'm confusing myself. So obviously we want to have 1 and 2. Fantastic, that looks good. And now we want to say that, not the species data, and the entities. We want to say entities, the second one, which is the owl. We want to set its target to be the first one. And now it moves towards the mouse. Fantastic. That's good. And now we can also add the trails back in. So we say connect the trail. What was a good size? Maybe 4, and we don't want to have we want to have this. So that's the color. Okay, not very exciting, of course, because the mouse is not moving. So the question is, how should the mouse move? So let's say that the mouse let's say entities 1, velocity. So what I'm doing, what am I doing? The velocity is the actual velocity. So this is entities 1 max speed times, let's move it to the right. And then we get this classic pursue curve. So let's start at -5 and -5 and 20, and then fantastic. Now we can also see what happens if the owl is faster. Oh yeah, another point, of course, is an owl and a mouse in the same plane might not be the best thing, but it's okay. And the owl is significantly faster, it should be able to catch the mouse. Right, just by moving towards the mouse. But that's of course not necessarily what we want to have here. Something like this. Fantastic. Now let's make the mouse move in a more interesting way. So I don't want to set the velocity directly, or do I? So what I'm thinking is I want to make the mouse move in a sine curve just to have something a little bit interesting. It doesn't really matter. But it would be nice, it would be easier if I set the position directly. So again, it's a little bit against the generalization of what we want to have, but that's okay. So let's say so let's make a secondary. It's really stupid, but entities 1. So now, right, now only the hunter, only the owl is moving, and now we can set the position of the mouse directly. Let's make that before we move the owl. So we want to say entities 1 position is, let's give it a name. So this is mouse start. Mouse start, mouse start. Then what did I say? Sine curve. So now in my package is always the absolute time. Oh, that's very right. So. Of course, it now moves faster along the curve, but that's okay. Right, maybe something like this. This would be a good introduction to Cursive Pursuit. And we see a little bit of wobble. In the owl path, so maybe make the frequency a little bit faster. I don't know, maybe. And let's make that. I'm too lazy to calculate the actual velocity along the curve. It's probably 1 plus square root of 1 plus cosine. Right, and now we want to see how the owl is actually moving. Right, it's okay. We can make it make it better if you want to, but it's okay. And now I want to see what the owl is doing. So I want to draw from entities 2 position to I want to have a ray which goes past the owl. So I want to go to the owl, but I want to go way beyond. So let's say 5 times more, then we should be safely off screen. And we want to do this in maybe in a brighter teal, and now the color obviously. Oh, what is going on? So because I mean it looks like a laser scope, but I think that's okay. Let's make it dashed. So maybe 2. Still looks like a laser scope, but that's okay. Maybe that's okay. But I also want to have on top of that an arrow. So let's call it the direction. Oh no, I don't need the direction. I have the velocity, right? I have the velocity. So I have draw the position plus the velocity. And that I want to make in 5 and not dashed, but an arrow. Let's see. If I make it 10, right. So this is the idea. That does not look good. Let's forget this dash. Let's make it a straight line. It's still not. Maybe it's better to leave that out. Yeah, let's make it twice as large. And then maybe something like that. And of course we want to have that, oh my, we want to have that above the trail. Maybe. I don't know, is that a good visualization of how it actually works? Of course there's a little glitch at the end when the arrow goes off screen. That's always a problem in Cindy. Is that okay? I don't know. Let's make the mouse start here. And I'll... I am not satisfied with that. Getting close to an hour, so I don't want to overdo it. I don't know. Let's make a somewhat like round animation out of it. So we want to have what do we want to do? Make so in a lecture or video you would say we have a mouse, we draw the owl, and then we draw the arrow, and then here at the start, at start, what looks like? Personally, I think green could be a tad faster, but it's good. Yeah, that's probably very much dependent on what we want to use the animation for and what kind of effect we want to have. But yeah, overall, the owl could be fast, but it catches the mouse very quickly anyway. Yeah, like these are things I will spend hours on. It's probably also not a good idea to have this on a sine curve, but yeah, maybe 4.5. Right. Yeah, it's okay. It's for a standalone single animation. I think we might want to optimize what kind of curves we want to show, but imagine it's a big lecture on differential geometry, and then it's just one example of many. So what do you want to do? You want to draw the mouse, draw the owl, draw the arrow. At the start of movement 4, we want to start our animals. So I imagine the voiceover for such an animation would be, imagine we have a mouse, imagine we have an owl or a hunter, and everything the hunter does, and the only thing the hunter does, is move towards the prey animal at every point. This would be the arrow. What we get out of it is a so-called curve of pursuit. So I think if this goes on for 2 seconds, we can fade out arrow. So then it would be, if we look at the path the hunter and prey, the hunter follows, it's a so-called curve of pursuit. Then we can get rid of the arrow, and then we don't have the issue that the arrow clips through the mouse icon. So, and then we do the same again as we did before. Again, it's very over-engineered. So let's make that separately. So we have entities 1 and 2. And we said we want to make 1, this is the mouse, pop up, so ease out back with T1, ease out back with T2. What is going on? Ease out entities 2. Oh, right, we want. Right. Let's stop the movement. Let's stop the movements for a second. Oh, the mouse is very, very, very far to the left, so let's make it maybe 9. And where is the owl? Let's make it 18, 19. Fantastic. So imagine we have a mouse, imagine we have an owl, and all the hunter does is move towards the prey animal. So we want to make the arrow appear. So first of all, we want to have the length of the arrow increase. So let's make that ease in out cubic. That's nice. We make the size, right? Ease out back. That's good. Then let's go to the trails for a second. We make that if, when are they starting to move? At 4. If T4 started, we draw. Oh, that's if T4 started, we draw the trails. Imagine if mouse always move towards the target and then we start, right? So we say we have this here, so we do the same trick as before. If T4 is 0 or above 0, we multiply by 1, otherwise by 0. And we do the same for, maybe not here, maybe here. Very, very crude, but it's okay. What is going on? With the mouse, we have a hunter. The hunter moves towards the prey. Oh my god. Right. So this is because I'm using the absolute time and not the time since number 4 started. Right. So this is mouse time. Mouse time. What is mouse time? Mouse time is the absolute time minus the start of track 4. Hopefully. And let's make one little thing. So I want to make the mouse start slightly earlier than the owl. So let's say the owl starts, the hunter starts if we are, let's say at the end. Let's say at the end of track 4. Maybe that's okay. And now we want to fade out the arrow. So that's the arrow, right? So alpha is, and I want to make it fade out. So this goes on for, let's say, 2 seconds, and then in 5 I want to make it fade out. How is my fade out working? I think with ease in circ 1 minus T5. That gives a snappy fade out, I think. Right, and then we can say, if we only focus on the pass that the hunter is making, right, and it's very close at the end when they leave the screen, which is also very good. So yeah, that would be my second animation for that explains. So the task was how a curve of pursuit is generated. So that animation would help in explaining how it is actually done. Where we have a more or less arbitrary path for the prey animal, and then the hunter will just move in an appropriate way. And then we also have the other version where we can say hello, hello, hello. Did I not rename it? It is renamed. Why, what? That's still there. Local okay, I'm very confused. Somehow a .com was added. Right, and this is the second animation where one could talk about how if we know, or if the movement is somewhat structured, then those pursuit curves are also structured. In this case, it's a logarithmic spiral, and yeah, we have two things, so we can use these animations for like more general differential geometry or for more concrete applications. So let's look at them again at the end. We have our mice problem. And we have this more general pursuit curve. And that's how curves of pursuit are generated, at least according to me and Cindy.js. And we're still over an hour, but we're under 1 hour 15. We're getting a little bit faster. Thank you so much for watching. And yeah, we will see each other next month, I'm sure, for the next animation generation collaboration. Goodbye.